Good morning, students. Today again we start the differential equation series of higher order linear differential equation. The objective is the same that after the students you all are able to complete solution to do the complete solution of differential equation. So without wasting time we are starting the some example and some problems which are very important with respect to time, with respect to exam. Now let's start. First of all, I write a problem which we will discuss in today's lecture. Question 1. D square AD plus 2 y is equal to sin 3x plus x square plus x. Second is that d minus 1 whole square d square 1 is equal to plus e to power. These are the two examples or problems we will take in today's lecture. And first, I start with first one, solution first. D square minus 2 is equal to sin 3x x square plus x. Okay. Now make auxiliary equation m square minus 3m plus 2 is equal to 2. Okay, so this can be rewrite and m minus 2 m is equal to 2m. These are the two root of the auxiliary equation. We know when the root are real and distinct. So here the CF becomes here is equal to c1 e to the power 2x plus c3 e to the power. This is the equation. This is the equation 1. Now we move in pi. Take this side pi. Pi is equal to sin 3x x square plus x plus e to the power x. Okay. Now we separate the term sin 3x upon d square minus 3d plus x square plus x plus e to power x. Okay. Now, now is e to power x to e to power 3 whole x right now. No issue, we take e to power x and e to power x is okay. Now, first we see that sin 3x means sin alpha x. So we can replace d square as minus alpha square. So sin 3x minus 9 minus 3 plus 2. Here, comma, here we alpha is equal to 1. When we put 1, this will become 0. So we multiply with x and differentiate with respect to. Okay. Now, this becomes sin 3x upon minus 3d minus 7 plus half we take above plus here we put 1, then it will convert in to minus half. Where we apply this, here is sufficient. Expand it till here because here is the maximum power of x is x square. Here this becomes x is power. Now this is the first term. Here 3d plus 7 we have to change d in d square, so we multiply 3d minus 7 sin 3x plus half 1 minus d square minus. Here we get 1 upon 4 d4 9 d square minus. This will become 360 x square plus alpha x square plus x minus x this. Now 3d minus 7, this will become 9d square minus 14. sin 3x plus half. We take x square plus x inside. X square plus x minus of. When we differentiate about 2 times, then we get 2 only. X will become 0. Minus plus 3. 2x plus 1. Minus 1 by 4. 9 by 4. This square again. Here we put 3d minus 7. No problem here. Here we do minus 3d minus 7. 3d 9d square minus 14. 9 plus half. Here we take inside x square plus x minus half. D square becomes 2 plus 3 by 2. 2x plus 1 minus. Okay. Now we replace d square by minus alpha square. So it will become 9 minus x square plus x minus 1 plus 6x plus 3 by 2 minus 9 by 2. Now we can do minus 3 7 minus 81 minus 49 sin 3x plus half x square plus 7x plus 3 by 2 minus 9 by 2 minus 1. X is 1 by 130. 3d sin 3x and 7 sin 3x. Square plus 7x. Simplify all the terms, it will become 1 upon 30. 3d become 3 cos 3x dot 3 minus 7 sin 3x plus half minus 4x. 8, 11, 11 minus 4 minus x e to power. So this is, by simplify, we get 139 cos 3x minus 7 sin 3x plus half x k plus 7x minus 4 minus x equal. This is the our PI. I know that PI is very lengthy and the terms are so lengthy, but we have to do simplify it. By simplify, we can need not to much simplify. This is sufficient. Now we add 1 and 2 for complete solution. So CS is become y is equal to, we have P1 complete solution C1 e to power 2x plus C2 e to power x plus 130 9 cos 3x minus 7 sin 3x plus x square plus 7x minus 4. This is a complete solution. Okay. So I explain again, this question is very lengthy to solve PI. So again we will see. First we write auxiliary equation. We find the root of auxiliary equation, then we find PI. Auxiliary equation root are m is equal to 2 and 1. So the CF is P1 e to power 2x plus C2 e to power. Clear? Now now we have done CF. Now for PI. PI means particular integral. We need to write in 1 upon FD form. Here we write 1 upon FD form, and this is the, now if sine 3x upon this, x square plus this and this. Separate the all terms. Okay. Sine 3x upon FD, x square plus x upon FD, and e to power x upon FD. Now in first term sin alpha x, this is the become sin alpha x term. sign. So here alpha is equal to 3. So we know d square replaced by minus. Then x square plus x d square minus 3d plus 2. Here we take 2 common. This become 1 plus d square minus 3d upon 2 and plus x e to the power x, and d replaced with alpha. Alpha is equal to 1. There is plus. Here 3 minus 3d minus 7, 3d plus 7 now multiply by 3d minus 7. So the d convert in d square plus half inverse, this is expand form till x square. So either m is equal to 2, so we expand till square and x. Here when we put alpha, alpha is equal to 1 is converted 0. So we multiply by x and differentiate with respect to t. So x e to the power x 2 minus 3. So when we solve it, now become 3d minus 7, 3d minus 7, it become 9d square minus 49 and put d square with minus alpha square minus 9. This is the expand form, we solve it and now x e to the power x, this is the form e to the power x. Now just simplify the terms and okay, just simplify, we get the here. Concept is same, but the length of the question is heavy. So there are some mistakes students have done in the exam with respect to calculation part. So do carefully. Now the second example. We turn to the Now we turn to the second example. D minus 1 का whole square. Now we turn to the second example. Sine square x by 2 plus e to the power. Here the auxiliary equation is same. Friend, you can try also this question. The auxiliary equation m minus 1 का square m square plus 1 का square is equal to 0. So here we get m is equal to 1 1 and m square plus 1. And so here we get m is equal to plus minus m is equal to plus m is equal to 1. There we get 6 roots. So the CF C1 plus C2 x e to power x plus C3 cos x plus C4 sin. Sorry, the same roots we get C1 plus C2 x e to power x plus C3 plus C1 x cos x plus cos x and plus C5 plus C6. Okay, here we see the auxiliary equation we get m is equal to 1 1 m square plus 1 and m square plus 1. M we get C1 plus C2 x e to power x. C3 plus C4 x cos x and C5 plus C6 x sin. This is the our CF. Now for PI student. PI is equal to 1 upon d minus 1 whole square d square plus 1 whole square sin square x by 2 plus e to power x. Now we separate bottom. Now we separate bottom sin square this. Okay. Now, now we convert sin alpha x sin square. We can write 1 minus cos x by 2 plus e to power x. Okay. Now we already discussed about that. We open this 1 by 2. We can write 1 as 0 minus 1 by 2 plus e to power x d minus 1 का square d square 1. Understand? Now now we put actually here above the numerator is 1, so we can write e to power 0x. E to power 0x is 1. So here we put replace alpha is equal to 0. We put alpha is equal to 0 in this form, and 1 upon 2 0 minus 1 square 0 plus 1 minus plus 1, and here we write d square plus 2d square plus 1. Here we put if d is equal to 1 become 0, so we keep it as it is. This I what d is equal to 1, so we will convert in 2 ka. Okay. In d square plus 1 we put d is equal to 1. Okay. Now again you can see that 1 upon this is converting 1 plus 1 plus 1. It is converting to minus 1 by 2 cos this here we can put minus 1 square. So become minus 1 minus 2d plus 1. Here we can write d square minus 1 का square minus 1. So it will become 1 minus 1 का square minus 2 plus 1. This will be 0. So we cannot write here this one. We can put d4 plus 2d square plus 1. This one only. And this is become 4d minus 1. Again, I explained the first term, and now simply we can solve it by put x to multiply and differentiate downside. But first I explain about the pi. Here we see here we can see this can write this is the function and this is the fd. Okay, this is fd. So separate both functions here. We can write sin square x by 2 as 1 minus cos x by 2 and e gets this form. So we separate the both terms and 1 we can write as e to power 0x, e to power 0x, and this is cos x. 1 upon we put d, replace d with 0 because alpha is 0 here in this term. So replace 0, it becomes 1 by 2. Cos alpha x, alpha is equal to 1 here. So put minus 1 square, minus 1 square, minus 2d plus 1. Here we can write d4, d square, d4 as d square dot d square. And both places we have minus 1, it will become 1. So 1, and here we put minus 1. So this is cancel. So it may be converted in 0, so we left this. And e to power x. Okay, then now you should try this, complete this question by same method. This is the last question of this type of exercise. Now we move the variable coefficient. So this is for you to complete this. Now the time for cube. I'm moving for the cube. Okay, students, for the quiz. If 1 upon d fx means the integration of fx, this is the right sentence because 1 upon d is the differentiation of fx and 1 upon d is the integration of fx. Okay, qx is equal to e की power 3x, e की power 3x, then pi of fd. So when we write 1 upon d minus 3 e to the power 3 and d replaced with 3, it will become 0. Then denominator become 0. So we differentiate it. So e to the power 3x multiplied by x and denominator is become 1 with the, when we differentiate. So the answer is x e to the power 3x. Question x e to the power 3x. Yes, x e to the power 3. Pi of cos ax when fd is linear. Here linear means maybe fd is equal to d minus a, d plus a. Okay, both cases you have to discuss here. If d minus, see, I can take this with explanation of when given given that 1 upon 1 upon that fd is linear. So we can take case first 1 d minus a cos a. So d minus a means when we put d minus a, we multiply both d plus a. Okay, and cos x because we can replace d square as minus a square. So d plus a minus a square minus 2a square cos x. So this is become sin ax a minus plus cos ax minus 2x. And when d plus 1, this is the first case, when d plus a cos ax multiply with d minus a upon d square minus a. Same we get again. Here sign will be changed with minus. So definitely you understand. Now again on Q. Pi of sin 3x is 1 upon d by 2 d by 3. Here same when we put we multiply d by 2 and d by 3 become d square minus 5d plus 6. When d square replaced with minus alpha square means minus 1. So it can also be do easily. Find the P of e to the power 2x. If fd is equal to d minus 2, we put d is equal to 2, this will be 0. So we can easily do, all the practice have done easily. Now thank you very much students for listening and keep focus on constant coefficient method because this is the method is used for further process. Now in next lecture we will discuss about the variable coefficient. In variable coefficient we change variable coefficient in constant coefficient. Okay, so students keep continue with this series.